Hello, here is Jero. I want to show you my progresses in the GPU computing. I want to show you the different speed between four simulations. I will make this simulation on the catwalk, on the dress. I start VWD and I will import the collision object. Yes, you can see it is a catwalk. I import the clothes. I will import it using a high stiffness for the structure of the mesh and high rigidification by extension. I import the clothes and I apply the parameters. Okay, now I will create a link between the clothes and the body of the character. So I will apply a rigidification by nails to collision on the top, on all the top of the dress. I will make a selection of the top, full top of the dress, and I will apply nail to collision using a soft stiffness. So the links will be made using very soft springs between all the top of the dress and the character. To make the first simulation, I will use the most basic simulation, which is a simulation in a monoprocessor to see the speed. I start the simulation. Here is the speed with only one processor. It is very slow. Okay, very, very slow. I stop the simulation. And I will restart the simulation to make the second method. I regenerate the scene. All the settings are, all the objects are imported and the settings are applied automatically. Okay, the stiffness of the clothes and then the nails to collision. Okay. Okay, now I want to apply the second method. To make so, I will use this reading using a value equal to 8. As my computer has many processors, I think 8-thread processor on my computer is the same than i7 processor with 4 processors. I think it is the same, using 4 processors using the ePath reading. I start the simulation. The simulation is faster, but it is not very, very fast. Okay, I stop the simulation. Now I will re-import the clothes using the same method. Okay. The stiffness is applied. Then the nails to collision. Okay. Now I will restart the simulation using the GPU method. On my computer, I have two graphic cards, 970 and 1080. I will use for this test the small graphic card, which is a 970. I start the simulation. The simulation is faster. It is better for. We begin to see the movement of the dress. It is possible to see if a simulation seems correct or not very quickly. It is the advantage of the GPU computing. I stop the simulation and I re-import the scene. And now I will make the simulation using the high-level graphic card, which is a 1080. This graphic card is very powerful, but I know I don't use all the power of this graphic card. I have some progress to do. I will explain this during the simulation. For this simulation, I will make all the simulations using this graphic card. I start the simulation using the 1080. The speed is a bit better, and it is now possible to see if a simulation works correctly very quickly. We can see if the behavior of the dress is correct or not in some seconds. It is not a real-time simulation, but it is possible to see very quickly the behavior of a simulated object. During the development of the GPU object, I had to replace all the multi-level arrays to multiple simple arrays. In OpenCL, it's not possible to use arrays with several levels. It is really a problem because I had many arrays using this property. Many arrays can be defined at the beginning of the simulation, so it is not very difficult to. It is possible to define them at the beginning, so it is not necessary to generate them during the simulation. There is one array which is difficult to define because it is necessary to modify it during the simulation. It is the octaves for the character and the octaves for the clothes. The octaves are a structure that helps to find quickly a relation, a proper the neighborhoods of a vertex for clothes or for character. This accelerates the simulation. I have to find a solution for for this problem. The best way would be to be able to generate the octaves during the simulation in OpenCL, but for now I don't find a method. I will work on this part quickly. Okay, you can see simulation. The animation of the character is not perfect, but it's not really important for the demo. I made several tests between the monoprocessor, multi-threading on different graphic cards simulations, and the results are quite the same. So it is very good, very good news. Well, I hope this demo will help you to understand the progresses in OpenCL computing. Thank you.